Good afternoon, everybody. It is once again Ted the Speed Learner, and this is Algebra 2 Common Core. I know the title says Common Core Algebra 2, but that's interchangeable. Okay, now then. I know you're going to be asking, what is this? What is all this? What is that? And I know you have a lot of questions, and I will answer every single one of them in this particular video. But the first thing I want to tell you is why I'm creating this particular video series. Well, the reason for this is that I found out that the Algebra 2 that I learned as a kid is not the same Algebra 2 that you guys are learning now. Oh boy, is it different. What have they done? They have mixed Algebra 2 with René Descartes, which, by the way, I'm sure you people recognize this if you've been watching my videos on a regular basis. This here, these two number lines, this horizontal and vertical number line together, that makes up the Cartesian coordinate system. This was introduced by René Descartes. And yes, I have a whole video series on René Descartes. I know I have never finished it, but there are good reasons for that, and I'll cover that later. But they have mixed up Euclid, René Descartes, statistics, yeah, they got statistics in this thing too, surprise, trigonometry, and a few chapters of calculus just for good measure. No wonder the kids are all mixed up. My gosh. Oh, and let's not forget all the mathematical terminology they've introduced to this as well. Whew. And you wonder why the kids can't do any of this stuff. Well, we're going to get into this right now. Alright. The first thing that these people have done is they have introduced terminology that didn't really exist in Algebra 2 and really doesn't exist in much older math books. That's right. All this a lot of this terminology I'm going to introduce to you today has been invented recently. So no wonder nobody knows what you're talking about. Okay. First of all, what is this word right here? This is called etymology. We are going to study a lot of etymology in this series. I'm sorry, but that's exactly what we're going to do. Now, etymology is the study of word origins. That's what it is. And we're going to start with a word called interval. What is an interval? Okay. Now you have to keep in mind, much of the etymology I'm going to present in this video series comes from the Latin language, the language of the Romans. Some of it also comes from the Greek. You see, it comes from Greece? Yes, because a lot of mathematics was invented by the Greeks, including Euclid. That's right. Euclid's elements came from Greece because Euclid was a Greek mathematician. So was Aristotle, and I could go on and on and on, but I'm not going to. At least not in this lesson. We'll cover all that later. Even the Pythagoreans. That's where you get a lot of this stuff from. It was from Greece. Okay. So anyway, if what I tell you in the line of etymology does not come from Latin, now keep in mind one other thing as well. When you're talking about Greek terminology, a lot of the times because Rome did a lot of trading with the Greeks back in the old days. And so they integrated a lot of that Greek terminology into their language. So it may have started off as Greek, but then it became Latin, and now you have it here. Okay, so if something doesn't trace back to Latin, it will trace back to Greek. You can do that all by yourself. Alright. The first word, interval. Interval has a prefix called inter and a root word called volume. Inter means between. Volume means rampart. Now you say, well, what the heck does a rampart mean? Okay. Well, we're going to do some etymology on that one as well. The word rampart, it started out with the French rampire, but if you go back a little bit further than that, you have the word ante, which means before, and parere, which means to prepare. So basically, let's say you're going to have a party. So what you would want to do is you want to prepare your food before you have your party. Because otherwise it would really be a disaster trying to prepare for your party right before your party. You might get the food preparation done, but then you wouldn't look very good because you've torn yourself up preparing all that food. Get the idea? Now the word interval itself, deriving from this etymology, actually means a pause or a space. In mathematical terms, it means a number line without breaks. Okay? So, in other words, you would have a segment of a number line, say like from here to here, but there'd be no breaks in between. That's what that means. Alright, now what is a set? Now I'm not going to trace the etymology of the word set. This one's pretty simple. It refers to a collection of things, like toys in a toy box. Or, let's say you're a stamp collector, and you have a special folder or book or whatever where you put all your stamps in. That's a set. Now, in mathematical terms, it's a number set. Okay? You have a series of numbers in a particular set. Okay? Now, what is notation? The plus sign is a notation, so is the minus sign, and this means function. Mathematical notation refers to mathematical symbols that represent written statements. So if you say, I want to find the function of x, you'd write this, instead of writing out some giant sentence. And I know in elementary Common Core math, they make you write out these most ridiculous sentences. It's a complete waste of time. I'm sorry they make you do that, but that's what they do. Okay? But anyway, if you're looking for mathematical notation, your plus sign, your minus sign, these down here, these are brackets, these are parentheses, these are braces. These are all mathematical notations. That's what they are. Now then, what is an equation? Well, this right here is an equation. 4 plus 5 equals 9 is a mathematical equation. That's what it is. Now, if a mathematical equation includes the greater than, this is the greater than symbol, or the less than symbol, then it's called an inequality. Why is that? Because if you take a look at this, is 6 the same value as 4? Well, no. If you have 4 apples on one end, now let's just imagine a pair of scales here, okay? And I'm sure you've seen these, like this, and like this, and they got, you know. Now, if you have 4 apples on this end of the scale, and you have 6 apples on this end of the scale, this one's going to go down, and this one's going to go up. And why? Because this one will be heavier than that one. Get the picture? As a matter of fact, a lot of your early mathematics was derived because of land ownership. Because remember, you had to have land markers to show what property was yours and what property was your neighbor's. And it was also derived from commerce, which means the exchange of money for goods. Okay. As a matter of fact, I'm going to throw another little terminology in here. It has absolutely nothing to do with mathematics, but I'll go ahead and throw this in anyway. In the old days, people used to trade gold for merchandise. Isn't that nice? The way they determined how valuable the gold was that they would scrape the gold against I don't really want to say brick per se, but it was a special type of rock called a touchstone. And depending how the gold rubbed on the touchstone told you how valuable your gold actually was. Neat, huh? Just a little tidbit for you. See, you've learned something new already. Alright. So, now, what have we learned so far? We learned what etymology was. We learned what interval was. We've learned what Rampart was. We've learned what a number line is. This is a number line. We've learned that number lines came from René Descartes. We've learned what a number set is. We've also learned what notation is. All this is notation. This is an equation. This is an inequality here. 6 is greater than 4. We've also learned that this is brackets. This is parentheses. These are braces. We've learned what a touchstone is. We've learned what gold is. Think of all the stuff you've learned so far. Is all this stuff starting to make sense to you now? Hope so. Okay. Brackets are used to include endpoint coordinates in an interval. Now hold it right there. What's an interval? This is an interval. This is a part of a number line without a space in between. Okay? Now, what's the endpoints of an interval? Well, let me show you what the endpoints are. This is an endpoint, and so is this. Those are these are the endpoints of intervals. Okay? Now, if you use the brackets, you're saying I'm including all the numbers between here and this number and this number. If you use parentheses, on the other hand, you're including all the numbers that are in between here, but you're not including this number or this one. You're leaving these out. Okay? Now, what the heck is an asymptote? And I know I'm not the best at pronouncing asymptote. But anyway, it is actually a Greek word. It has a prefix called a. Okay, the a is the prefix and it's called not. Okay. Now, SYM was originally written SUN, which means together. Okay. And then we have PTOTOS, ptosis, which was the root word which meant apt to fall. Okay. So, what is an asymptote? It's a line that doesn't meet. That's what it means. Now then, the next thing they came up with in this, and this comes directly out of calculus, is they came out with the term LIM. And you'll see a little arrow here type thing. And I actually discussed this in a previous video. I will look that up very, very soon, and I will leave you guys a hyperlink to that right underneath this video. I'll leave a hyperlink in the description down here just as soon as I find it. But anyway, that's the limit. And what that means is that a number, when it approaches another number, will have values. But if that number actually hits that number, say, let's start with this. As 4 approaches 0, then the numbers will have value. But if the number goes from 4 all the way down to 0, okay, if these two numbers end up being both 0, there is no value. And I'll show you a perfect illustration of this. Let's say you have 5 divided by 0. You can't really divide 5 by 0. You can't divide 5 by anything. Let me try to say that a little bit better. It would be like trying to divide a pie if you don't have a knife. You can't divide a pie without a knife. It doesn't work that way. Oh, sure, you could use your hands, but it'd be kind of messy. So if you want a clean way to divide a pie, you have to have a knife. Same thing here. You really can't divide the number 5 by the number 0, because basically what you're saying is, and I said this in a previous video, 0 is the absence of value. That's what it is. In mathematics, it is called the absence of value. That means that particular number has no value whatsoever. It'd be like having a piece of scrap paper that you suddenly throw in the garbage. To you, it has no more value. Why do you think you put stuff in the trash? Because it has no more value to you anymore. Might have value to somebody else, but it has no value to you. So, what this actually says, when the limit thing, is that when your number here matches that number there, this equation will no longer work. Okay, it'll produce a false result. And that's what that means. Now then, the next thing they did was they introduced something called the conic section. And I have not fully covered this because I have not shown you people how to create an icosahedron or a dodecahedron in Euclid Book 11. As soon as I do, I'm going to go through all those Euclid proofs and I'm going to show you, okay, how the conic section actually works. But I'll give you basics on this. Now let's imagine here that we have a cone like this. Now we take a slice off that cone. Okay, we're going to actually take a plane off that cone. If we do, we can form something called a parabola, which is a curve much like this. Or we can form two parabolas, and I know this is kind of a stretch. It's not exactly like this, but it's kind of like this. And I will get more specific as I go on, because hyperbolas have a more specific definition than what I'm... This is just kind of be a general definition, and I'm going to get a lot more specific in a later video. But basically, if you have two parabolas, and they're basically identical, except for the fact that one's in the positive part of this graph and one's in the negative part, okay, then if you have two parabolas like this, you have what is called a hyperbola. One is a parabola. Two are hyperbola. But that is an extremely generic definition. It's far more specific than that, and I will get into that in a future lesson. But hopefully now you guys can see what's going on. Alright? Now, they have these two words. They're called domain and range. Now then, I explained this in a previous video. If you look up my trig videos, you'll find this stuff. Okay? Domain is one number set and range is another. Now the difference between these two is this. The numbers in the domain, let's just say these numbers in the domain are actually human beings, okay? And these human beings are told that they can only marry one person in the range. Okay? So if you're a guy, you're only about and all the numbers in the range are girls or ladies, okay, as ladies. So you guys are told you can only marry one lady. But then the ladies are told in the range that they can marry as many guys as they want. Talk about not fair. But when you're matching one number of the domain to exactly one number of the range, no matter how often the range matches it matches more than one from the domain, you got yourself a function. And there's your function right there. And hopefully all of this terminology will finally become clear to you. I know I have explained quite a bit, probably overwhelmed you, but now you're beginning to realize what they have done to Algebra 2. When I took Algebra 2, it was not nearly this complicated, but I guess times have changed. Anyway, I hope all of this has assisted you. I know I'm exhausted. Alright. Well, this is Ted the Speed Learner signing off. I will tell you more in a future video, so I want you to stay tuned.